New half-bridge package with built-in 4th generation silicon carbide MOSFET. Hello, welcome to Bodo wide bandgap event. First of all, thank you very much for Bodo organization. My name is Muzaffer Albayrak. I am working ROHM Semiconductor as Applications Marketing Manager responsible for energy conversion. Today, I will introduce a new package from ROHM in half-bridge topology, where the latest ROHM silicon carbide technology is used. In total, the presentation would have roughly 10 minutes. Therefore, this presentation will mainly focus on the new package from ROHM and its key benefits. Please feel free to contact us if you need more detailed information. Before going into specific details, let us start with the agenda. As first, introduction of package structure and lineup. Then, I will show some advantages by using this package, such as thermal characteristic, power cycle capability, and assembling instructions. Finally, I will show one example topology with DOT 247. At the end, we can start with the question and answer session. It's well known that wide bandgap devices such as silicon carbide power devices contribute to greater energy savings and excellent system miniaturization. In this page, I would like to introduce the new ROHM solution in 4 categories as an answer for wide bandgap. As first schematic, left top side. Principally, DOT 247 is a similar construction of 2 serial connected TO247 4 leads package, which has been realized in 1 lead frame. This structure brings several design benefits. Next, into the dimension. Like the standard TO247 package, this new package also doesn't have their own isolation. Therefore, additional isolation to heatsink is necessary. And size of TO247 is roughly 2 times individual devices with TO247 4 leads package. Of course, this structure brings several design benefits. Left bottom, some benefits are very shortly listed up. I will introduce some of these topics more in detail in coming pages. To warm up, I would like to mention it in advance. Improved package due to not having of screw hole. DOT package allowed a better thermal dissipation, which has effect also for improvement of power cycle capability. But in coming pages, you will then get more detailed explanation about this. Also, the using same lead frame reduce the internal inductance between high side and low side switch, which allow to higher switching frequency. Finally, DOT offers a suitable lineup and also automotive qualified version. And 4 quadrant right bottom sides, we are giving information that the evaluations kit and datasheet are available. Let's go to the next page. In this page, I would like to inform you that we will reach the mass production status after middle of 2023. Currently, we are able to provide some limited number of samples by request. The promising lineup meets the market requirements with low RDS on levels. For 1200 volt, from 80 milliohm up to 6 milliohm devices, and on the other hand, for 750 volt, from 30 milliohm to 4 milliohm devices. Now we can start to give more technical details of DOT package. Let's start with the thermal resistance comparison versus conventional TO247 package. By elimination of mounting hole, more area within the package could be achieved, which leads to a balanced overall heat dissipation. As a result, thermal resistance junction to case, also the thermal resistance junction to ambient, can be improved in comparison to TO247 package under same conditions. The thermal resistance junction to case is roughly reduced by 35%, and also thermal resistance junction to ambient reduced by 23% with the new package. So, but did you think about what would be other effects of better cooling? So with this question, we can step into the next page. Power cycle capability, which generates stress on power devices due to delta T junction temperature pulses. One of weakest point on the chip during the power cycle test is the bond wire. In dot package, we used copper clips instead of traditional bond wires, which helps to improve power cycle curve significantly, roughly 4 times more than bond wire. The conditions which has been used by performing power cycle tests is shown here, right top side. 2 seconds out, 80 seconds off, between temperature 50 to 150 degrees. Now we are coming closer to the end. These slides show one of the typical methods of mounting with leaf spring. Such kind of devices without screw hole is not new. Therefore, you can easily find the matching spring for the mounting. But we need to consider the isolation foil anyway. Additionally, due to package type, reflow soldering cannot be applied because the dot is a through hole device. On the end, to make whole picture more understandable, I will show a simple example application with .247 in the next page. What you can see here is a bidirectional topology of DC wallbox charger up to 22 kW. On PFC stage is a B6 bridge topology, SPFC. On the DC-DC stage, a bidirectional LLC topology. The well-known trend in charging station up to 30 kW is most of the times designed based on the discrete devices. Without having big design changes, the whole power stage size can be reduced up to 20%, which allows more compactness and quicker assembling time. So, finally, we come on the last page. Last but not least, ROHM offers worldwide with sport materials like aviation sport, simulator, and also own benchmark possibilities. The wide engineering network allows to help you at your design activities as quick as possible. So, this was the last sentence of my presentation. We tried to keep the presentation as compact as possible to fit into the allocated 10 minutes. All detailed questions could be addressed also offline. Now we have reached the question and answer session. Thank you very much for your attention.